Hello, it's me again. I hear we have a new heparin protocol lineup. So I wanted to work one of these with you. Let me switch cameras. Okay, so um, looks a little different, but there's all of our stuff that we used in the healthcare class is still there. It's just kind of hidden. So the following question refers to your patient who's on an IV therapy according to blah, blah, blah. The patient weighs 210 pounds. We are going to get to use that. And on admission, the patient's APTT is 30 seconds. You initiate IV heparin therapy, record your answers, blah, blah, blah. Okay, so it looks like they've numbered all the line items, which is kind of handy because then we can refer back to which line item we found everything on. So for all patients on heparin drips, we do need to figure out their weight in kilograms, okay, because a lot of this stuff is kilogram based. So we're going to get to do that on this first question here. But it's telling you that your heparin concentration is this units in milliliters, and then the bolus concentration is that. So just like we did in the math for healthcare class, there are two different concentrations we're working with. So I'm going to highlight them just to keep them separate. So our drip concentration is going to be in the pink, and then the bolus concentration is going to be in the green. And that just kind of helps me keep track of where I'm supposed to be finding things. Now these next couple of lines, I don't think we really need them for the protocol. I'm not going to say they're not important, but for these questions they've asked, we don't really need a lot of it. So I'm going to go ahead and kind of draw some lines through those. Yeah, all that is just about how to, when to do your next APTT. Is there anything else we got to do every 6 hours? Write the neuro check, the DC APTT, CBC, once the heparin's been disconnected. So lots of important things, just not to this protocol. So I'm going to blur those out. We're not going to use a lot of that in there. But number 10 is telling us that a bolus, we need to use that kind of strength and start the drip at that. Okay, so here's our starting rates. Now, again, I'm going to go with green for the bolus and pink for the drip. Okay, so again, we'll come back to those as we need them. And then 11 through 15 is what do you do with the results? Once you get the APTT back, well, what's going to happen with all that stuff? So we'll use that as we need it. But the first question here is asking, what is the patient's weight as measured in kilograms? So desired answer is kilograms. We know the conversion 1 kilogram is 2.2 pounds. And our patient weighs, way back up here, we said our patient weighs 210 pounds over 1. So that puts us doing 210 divided by 2.2. It's going to get us a 95.454545. Now, it does say to round to the nearest 10 kilograms. So that would be this place right here. Okay, we got the ones place, we got the tens place. Now that 5 is big enough to make the 9 move up. So we're going to call that an even 100 kilograms. That's what I'm filling over here in the box, 100 kilograms. The second question, calculate the dose of heparin that it should be administered for the bolus. Okay, so these next two questions are asking about the bolus. All right, so let's go back up here. We want to know the units, right? That's what our question is asking about, the units. So up here in the green, we were told to do a strength of 1,000 units per milliliter, but I don't think we get to use that just yet. We need to figure out how much our patient's going to get based on his weight. So we're going to start with this 80 units per kilogram. So down in here, how many units is your patient getting? That's our desired answer. And we said we're going to work with the 80 units per kilogram, and our patient weighs 100 kilograms over 1. So that should work out to be 8,000 units. So we'll fill in 8,000 over here. Now the next one, calculate the dose volume of heparin that should be administered for the bolus for this patient. So this one is where we're looking for the milliliters. And up here in our protocol, that's where we're going to get to use this 1,000 units per milliliter. Okay, that's the strength. And again, we're picking on the bolus because that's what our question's asking about. Okay, we're sticking with the green for a while. So we're going to line this up that 1 milliliter has 1,000 units, and we need to give 8,000 units for our patient who weighs 100 pounds. So that's going to do 1,000, or sorry, 8,000 divided by 1,000. That is 8 milliliters. So our patient gets a bolus of 8 milliliters of heparin. Now, the next question, calculate the heparin solution volume of the patient should receive each hour to provide a correct infusion for the patient's weight. So the volume they should receive each hour for an infusion. Okay, so that's our pink numbers from above. So that one's going back to this concentration, 25,000 units and 250 milliliters, and it's going to happen at a drip of 18 units per kilogram per hour. So when this question is asking for a milliliter per hour, we need to go back and start with the 18 units per kilogram per hour, because we do have to get this weight-based for our 100-pound patient, or sorry, 100-kilogram patient. So working with the 18, desired answers milliliter per hour. We're working with, we gotta get milliliters in there. We can't start with the 18. I think we're gonna have to do both of these at one time. We're gonna have to have the milliliters. We can do milliliters per units and then units per kilogram per hour, and go ahead and put the kilogram in there too. Yeah, we're gonna have to do both of these at the same time. All right, so not the 18. Let's start with the 250. 250 milliliters is 25,000 units. And then the rate at which we're supposed to do this is 18 units per kilogram per hour. And our patient weighs 100 kilograms. All right, so let's check those. Units are canceling, kilograms are canceling. We have milliliter on top, hour on bottom. So that should be good. 250 times 18 times 100 is 450,000 over 25,000. And we get an 18 milliliter per hour. Yep, good deal. Oh, sorry, I wasn't showing you guys. I got on a roll. So we got that from line 2 above the 250 milliliters, 25,000 units. We got the drip rate from line 10, and then there's our 100 kilograms. We were making sure all those units canceled, and it worked out to be 18 milliliters per hour. All right, the next question. According to the protocol sample orders, how often should a patient's APPT be checked? What about up here? The APTT needs to be checked every 6 hours or 6 hours after a rate change. Once you get 2 consecutive APTTs, okay, if they're back to back and falling within the same range 2 times, falling in the same good range, the therapeutic ones, then we can just do it every day. We don't have to do it every 6 hours, but yep, I think we're gonna have to go with a Q6H. All right, now the back page. At 17:30, the patient's APTT was 38 seconds. Rebolus with heparin. So we got to figure out how many units and how many milliliters, and then we got to figure out our new infusion rate. So again, this is the green lines, the bolus, and the infusion rate goes back to the pink numbers. Okay. So a rebolus with heparin. Now, it does fall in the 38 seconds. So up here in your protocol, that would be this one right here, right? So it's saying to rebolus with, it's a bolus. We'll put that in green. And then we're going to increase the rate. That one's going to be in pink. Okay. Rebolus. We're going to have to go with this 40 units per kilogram. Now, first of all, we have to look for units. And we're going to go with the 40 units per kilogram. Our patient still weighs 100 kilograms. So we get a 4,000 units. So let's write that in over here, 4,000 units. How many milliliters is that going to be? Again, this is still the bolus. Okay, so we're going to the green lines up here. We rebolused with this, which took the place of that one, right? That was our initial bolus. Now we rebolused with that. So we need to figure out what strength. Oh, no, sorry. I got that backwards. This was our initial bolus, and we half strength it. Okay, but we're working with that concentration, that there's 1,000 units per milliliter. So when we're trying to find how many milliliters, we know that 1 milliliter is going to contain 1,000 units, and we need to give 4,000 units over 1. So that should work out to be 4 milliliters. 4 milliliters. And you'll notice, I mean, this is going to be the half strength, right? Because our initial bolus worked with the 80,000. Okay, so we worked with 8,000 units, and we were working with the 8 milliliters. Now we've cut those in half because of that protocol up here. The initial bolus was supposed to be 80 units per kilogram. We're cutting it down to 40 units per kilogram. Okay, now if you landed in the number line 11, yeah, we could have been a full strength bolus with that 80, but we did a half strength. Okay, the next question is asking about our new infusion rate. Okay, so up here in our line 12, I might want to put that over here to the side. This is line number 12 that we're getting all this from. Line 12 is telling us that we have to increase the rate by 2 units per kilogram per hour. So we're not going to work this problem with 2. We need to increase the rate. And you got to think back to what was your original rate. Up here in pink, we were working at a drip rate of 18 units per kilogram per hour. We were using this strength. Okay, that's how strong the medication was, as opposed to this. Okay, and this one's a little stronger. So we got to figure out this. Okay, so let's write this down as that the old drip rate was 18 units per kilogram per hour. And number 12 is telling us to increase by 2 units per kilogram per hour. Okay, so we're going to add that to it. We're going to be working with a 20 units per kilogram per hour. So when we run our math here, we are looking for milliliter per hour. And we need some milliliters. That's all units. So back up here at the top, we need that concentration strength up there. So let's do 250 milliliters is 25,000 units. And then we need to work this with our 20 units per kilogram per hour. And our patient still weighs 100 kilograms. So kilograms cancel, units cancel. We have milliliter on top, hour on bottom. Good to go. So when you multiply all those top pieces, we get a 500,000 divided by 25,000. And that should come out to be a 20 milliliter per hour. So 20 milliliter per hour there. Now, if you're trying to make a connection here between this units per hour and this 20 milliliter per hour, I'm going to say it's not always going to work. That really depends on the strength that we're working the problem with here. Okay. This one does in fact kind of work out that way. Even if you go back and look at the other drip rates that we were looking at, we were working with the 18 units per kilogram, and we wound up with an 18 milliliter per hour. Okay, but again, it's because that strength of the heparin we're getting. Now, if this was something like a 500 milliliters and 25,000 units, it's not going to work out that way, that those numbers match. Okay, so I don't want you to fall into that habit of those are always going to match. It really depends on that strength. Okay, and that's going to change, I would imagine. So, all right, I hope this helps.